What will be tomorrow? Every evening, as we prepare to rest, we ask this question to ourselves. It is perhaps the biggest mystery for all mankind. We can't help but wonder what the future has in store and worry about the uncertainties that may lie ahead. Everyone would like to look a couple of days or years ahead into the future and see what their life will be like. Will I be living the life of my dreams? Or is something really painful waiting to happen? Well, what's the worst that could happen to me? Death. Death shall ultimately claim us all. No one currently in recorded history has cheated death, and no matter how much we try to avoid it or delay it, death will come to us all eventually. Billions of years into the future, when the sun swallows the earth, or whether a cataclysmic event like an asteroid impact occurs, our existence will dissolve into minuscule atoms scattered throughout the vastness of space, moving haphazardly through the cosmic expanse. We'll return to the very particles that once birthed us. Essentially, we'll once again revert to a state of non-existence. However, the universe will continue its progression. The sun will still rise and set on countless planets. Seasons will change, and the tides will ebb and flow. Stars will be born, and planets will form, sustaining the ever-evolving web of life. The cosmos itself will continue to expand and evolve over time. All events unfold as they have in the past, with the exception that this time your physical form has transitioned, rendering you unaware of the transformation. Consequently, you may not perceive the alterations transpiring around you. Thus, when you cast your gaze upon the night sky, remember that the stars above may be composed of atoms that were once integral components of a living organism. Space is a synonym of possibilities. It is a realm where even the seemingly impossible can be possible. And there are moments when anomalies arise that are hard to explain in a universe governed by fixed mathematical forces. Just look at the night sky above you. Why do the stars, governed by these immutable mathematical forces, scatter themselves in a state of complete anarchy? Why don't stars repeat patterns in the universe? Could this unorderly arrangement be a cosmic message, one that has been overlooked and evaded humanity's attention throughout the ages? A carefully crafted message from an otherworldly intelligence. And what about the countless billions of stars that dot the infinite universe? How is it possible that we're surrounded by an infinite number of shining stars, and yet the sky remains dark? If the universe is truly eternal and infinite, and the stars are uniformly dispersed throughout the vastness of space, then in any direction we look at, we should see a star. The light from these stars, however distant, would eventually reach our planet. Since time immemorial, every human inquisitive in nature has thought of these questions at least once. With the advancements and availability of state-of-the-art space tools at our disposal, we find ourselves closer than ever to unlocking the mysteries that have eluded us for ages. It's time to peel back the layers of enigma that obscure our understanding of the cosmos and cast a light upon these captivating mysteries of the universe. Take a close look at this picture. This is Eugene Cernan, seen here saluting the flag of the United States. The last person from the Apollo program to set foot on the surface of the moon. However, upon closer examination, you might notice something quite peculiar. There's not a single star to be seen in the background. In fact, every photo taken on the moon during the famous Apollo missions exhibits a sky devoid of stars, despite the fact that the universe is packed with countless sparkling celestial bodies. Even the Apollo astronauts themselves confirmed that they couldn't discern a single star in the lunar sky. This mystery has sparked all sorts of debates and conspiracy theories over the years, with some even using the absence of stars as supposed proof that the moon landing was a hoax. However, the explanation for this mystery delves far deeper than any conspiracy theory. In fact, the resolution to this cosmic puzzle once again leads us to a profound cosmic truth: the Big Bang. Why is space so black? The idea behind this query was first introduced by Johannes Kepler in 1610. Our Milky Way galaxy alone contains anywhere from 100 to 400 billion stars, and the observable universe contains roughly 100 to 200 billion galaxies. By this notion, astronomers wondered that since the universe is filled with a seemingly endless number of luminous, light-emitting objects in all directions, logically every patch of sky you choose to look at should contain thousands, if not hundreds of thousands of stars. This should cause the night sky to be uniformly bright in all directions. Careful analysis suggests that the sky should be as bright as the surface of the sun. This is not the case, however, which puzzled astronomers. It is a paradox that took nearly 300 years to resolve. The paradox had emerged from the steady-state theory, which was the most widely accepted viewpoint on the universe at the time. The steady-state theory said that the universe has been and always will be like it is today. And moreover, that the universe was infinite in size, had no beginning, and was uniform in all directions and did not expand. Initial attempts to resolve this paradox involved speculating that most of the stars were simply too far away to be seen. However, this explanation was quickly dismissed, as the steady-state theory itself posited that the universe had existed infinitely long, thus allowing light from even the most distant stars to reach us and contribute to a bright sky. Johannes Kepler came up with a different solution to the paradox by challenging the steady-state theory. Kepler suggested that the stars in the universe extended only to a finite distance, beyond which the viewer encountered only empty space. While this idea seemed plausible, of course, this solution prompted the questions: how far away is the boundary? And what lies beyond it? Additionally, the notion of a finite universe posed challenges, such as it would eventually collapse in on itself under the gravitational pull of its stars and planets. This led most astronomers to continue to assume that the universe was infinite, and thus the paradox and the steady-state theory remained as is, unresolved and forgotten. Until after nearly 2 centuries, when Heinrich Wilhelm Olbers, a renowned German astronomer, breathed new life into the paradox and once again asked the question, "Why is the night sky dark?" Since then, Olbers' name has been closely associated with the paradox. Once again, the common belief during his time was that the universe was static, infinitely old, and infinite in size. This time, Olbers had a simple solution. If we assume that the universe is infinite, it is logical to deduce that the opaque bodies in it would also be infinite in number, such as dust and rock that obstruct the light from distant stars, making them appear fainter. The cosmic dust gradually absorbs and blocks the light of stars as it journeys through space. Even today, most people subscribe to this theory, drawing parallels between it and the way clouds obstruct the sun's light and view. Cosmic rocks and dust likewise could eclipse light from stars. However, Olbers' compelling solution still does not entirely solve the problem, as any rock or dust would eventually heat up and radiate the absorbed energy. The universe would still contain the same amount of radiation. The dust merely acts as a mediator, so to speak, between the stars and the observer. Ultimately, the energy we detect on Earth would be the same. So, what's the solution to the paradox? The solution to the paradox would be revealed after a wait of another 100 years. In 1929, when Edwin Hubble peered through his powerful telescope, he hoped for a universe that would be collapsing, as that would prove a finite universe, just like Kepler said. But to his shock, he discovered that the universe was not collapsing in on itself, but rather the galaxies were moving away from us, as if the space between was expanding. In fact, the further away the galaxy, the faster it was moving away. The universe appears to not be falling in on itself, not remaining static, but expanding. This raised a new question. If the universe is expanding, then what does that mean for the early universe? Cosmologists now believe that the universe was once incredibly small and dense, and that it expanded rapidly in a phenomenon known as cosmic inflation. As the universe expanded, it cooled down and eventually stars and galaxies formed. This discovery ultimately led to the development of the Big Bang theory as we know it today. Scientists today think this happened about 13.8 billion years ago. It is the most accurate model of the birth of our universe. Today, most scientists think the universe has a finite age and that it started 13.8 billion years ago. When we look at 13.8 billion-year-old light, it's not that we don't see stars just because the light from them hasn't gotten to us yet. We don't see any stars because we're getting a glimpse at the universe before any stars had formed. A starless universe. The farther we look, the farther back in time we observe, until we reach the edge of the universe. This is not a physical edge, but instead the afterglow of the Big Bang, known as the cosmic microwave background, the farthest point in the universe that we can observe from Earth. When we point our telescopes past the earliest stars, we see this light. This is not starlight, but the light left over from the Big Bang, forming a background beyond the stars. But wait, the Big Bang theory seems to introduce a new problem. It states that the universe was much brighter in the past, especially at the end of the recombination era. All points of the local sky at that era were comparable in brightness to the surface of the sun, due to the high temperature of the universe in that era. So the cosmic microwave background should actually be dominating our night skies back on Earth, resulting in a constant need to wear sunglasses all the time to avoid being blinded by the intense brightness of the universe. Thankfully, this is again offset by the fact that the universe is expanding, and the expansion hasn't stopped after the Big Bang. Instead, it has only gotten faster, meaning new space is constantly being created even faster than the speed of light itself. At first sight, this may seem the violation of the principle of special relativity, which states that nothing can move through space faster than the speed of light. But in fact, it's not. The expansion of space is not caused by objects moving through space, but rather by the stretching of space itself. This stretching is due to the effects of dark energy, a mysterious force that is causing the expansion of the universe to accelerate. The expansion of space is measured by a quantity known as the Hubble constant, which expresses the rate at which the universe is expanding. Currently, the best estimates of the Hubble constant suggest that space is expanding at a rate of about 73.3 kilometers per second per megaparsec, which means that the distance between 2 points in space will double in size in about 9.8 billion years. Now, as you may know, light is a wave, and as stars move away from us, their light waves get stretched out. The human eye can only see certain wavelengths of light, and when the wavelengths get too long, we can no longer see them. This is called red shift, as red has the longest wavelength of all the visible colors. For very distant objects, the light waves get stretched so much that they become infrared, and we can no longer see them. So in a sense, the night sky is lit up. We just can't see it because of our limited human eyeballs. But telescopes can, and that is why we get to see such images. So finally, this is how the solution to the paradox plays out. Because of the finite speed of light and the fact that the universe has a finite age of about 13.8 billion years, this finite age means we can only see stars and galaxies whose light has had enough time to travel to us. The expansion of space-time complicates things even more. In the far-out regions of space, where space is expanding faster than the speed of light, the light from those galaxies will never outrun the expansion. No matter what we do or how long we wait, we'll never be able to see light from those galaxies. It will never light up our skies. What we see in the night sky is just a tiny fraction of the whole cosmos. We call this the visible universe, and we cannot, even with the most powerful telescopes, see beyond this horizon. It isn't just a horizon in space, it's a horizon in time. Beyond the edge of our visible universe, the light will never outrun the expansion. Due to this expansion, much further into the future, about 100 billion years from now, imagine we invent a powerful new telescope which will allow us to explore space beyond the galaxy. But as we peek through the telescope, we find nothing. Nothing but darkness and empty space. The generation of people have come to understand that they exist within a seemingly endless and almost informationless void. As the age of the cosmos approaches 100 billion, the expansion of the universe will cause all other galaxies to vanish beyond the cosmic light horizon. This means that light from other galaxies will no longer be able to reach us. Put another way, galaxies will be pushed aside out of the observable universe and can thus no longer be observed. Today, we lose about 20,000 stars a second, and if you think about it, we are rather fortunate to exist at a point in time when we have access to such an abundance of information. Sure, there are a lot of things about the universe that we do not understand, but at least there's hope that one day we will. The distant future of 100 billion CE, however, would be so information deprived that when they aim their equivalent of the Hubble telescope towards a seemingly empty region of space, the returned image would also be empty. Of course, the same is true today. We have no way of knowing what lies beyond the observable universe. But one final question remains. Why are these moon pictures devoid of stars? Surely, with nothing in the way like an atmosphere, we should be able to see some stars in the background. For this, we must learn how color is actually formed. Color is a complex interplay between light and matter. Light is composed of electromagnetic waves of different wavelengths. And when it interacts with an object, some wavelengths are absorbed by the object, and others are reflected or transmitted. The colors that we see are a result of the wavelengths of light that are reflected back to our eyes. For example, if an object appears red, it is because the object has absorbed all the other colors of the visible spectrum, such as blue and green, and reflects only red light back to our eyes. Similarly, if an object appears white, it is because it reflects all the colors of the visible spectrum, while an object that appears black absorbs all the colors and reflects none back to our eyes. We are able to see blue sky on Earth because particles in the atmosphere act as mirrors. The word literally means atmos, meaning vapor or atoms, and sphere, meaning globe. During the night, the sun sets and there is no sky to obscure our view of the stars. On the moon, however, there is no atmosphere to scatter light, but still we don't see stars. This is because the light from the sun travels in a straight line without scattering, and all the colors stay together. Looking toward the sun, we thus see a brilliant white light. This is what happened with the Apollo astronauts. Every lunar landing took place on the day side of the moon. Even though there was no atmosphere above them, the reflection of the sun's light from the moon's surface made their eyes temporarily blind. The high brightness intensity glare from the sun blinded them and their camera's sight of the stars. Though one astronaut reported being able to see some of the brightest stars when he was in the shadow of the lunar module, looking directly up with his protective visor raised. Imagine, though, if astronauts ever landed on the night side of the moon and have their eyes adjusted to near pitch black conditions. They would get a stunning view of the stars. If the Earth had no atmosphere then, even Earth's sky would look like the moon's. Currently taking into account light pollution and the limitations of the human eye, we can see roughly 3,000 stars during the night sky, and only about 300 stars on a full moon night. This is why some scientists believe it would be a great idea to spend money and time building a large telescope on the night side of the moon. The enigma of the Olbers paradox remains one of the most intriguing mysteries in cosmology, and its solution has provided a deeper understanding of the nature and structure of our universe. given the millions of billions of Earth-like planets, life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein. According to a recent comprehensive survey by Pew Research Center, 2/3 of all Americans now firmly believe that alien life does indeed exist. And at least 51% have full confidence that UFOs reported by people in the military are likely evidence of intelligent life outside Earth. And considering the significant and groundbreaking advances in astrophysics, scientists today firmly believe that there is a compellingly high probability of discovering extraterrestrial intelligence within the next few decades. Seth Shostak, a distinguished astronomer at SETI, Search for Extraterrestrial Intelligence, has boldly proclaimed that in a mere couple of decades, we will unequivocally uncover tangible evidence confirming the existence of intelligent life beyond our planet. As humanity casts its ever-expanding net across the vastness of the cosmos, capturing evidence of thousands of worlds, one ancient question haunts us. Is anybody out there? The vast expanse of the cosmos, with its many galaxies, stars, and planets, makes it very obvious that there is a possibility for life to exist elsewhere, even if we accept that the origin of life on Earth was a rare occurrence. The immense size of the universe serves as a large blank canvas for the diversity of life to emerge. It is a landscape that might include intelligent beings at all levels of development, ranging from the least advanced to the most evolved. Just imagine yourself alone, weightlessly floating in the vast expanse of space. The silence can be deafening, and the emptiness overwhelming. At first glance, you may believe you are truly isolated, devoid of companionship. However, contemplate the intricate ecosystems thriving inside our bodies, often taken for granted and ignored. Many microbes and tiny organisms may be living on your skin or within your digestive tract, their existence unbeknownst to you. While these organisms may not possess our level of intelligence, their presence serves as a poignant reminder that solitude can often be an illusion. Similarly, the idea that we are alone in the universe may also be a delusion. Unknown to us, life throughout the universe could demonstrate a vast range of intellect that we unconsciously overlook. Intelligence is an extraordinary feature that has profoundly shaped our own existence, and its manifestation can take diverse and fascinating forms throughout the vast expanse of the universe. On distant planets, creatures may have evolved remarkable and exceptional cognitive abilities, honed by unique environmental pressures and evolutionary pathways. Some civilizations may be less advanced than ours, perhaps comparable to the early stages of human development. They could possess basic communication skills, primitive technologies, and a limited understanding of the universe. While on the other end, many advanced civilizations may have surpassed our own. These beings might possess highly evolved intelligence, capable of extraordinary feats of knowledge, technology, and interstellar travel. Their scientific achievements and cultural advancements could transcend our current comprehension, rendering them godlike from our limited perspective. The diversity of intelligence in the universe surpasses the boundaries of our wildest imagination. The truth is, our self-proclaimed progress might potentially be minuscule when viewed on a galactic scale. In our quest to better understand the vastness of the universe and our place within it, scientists and futurists have devised various scales and metrics. One such measure, the Kardashev scale, proposed by the Russian astrophysicist Nikolai Kardashev in 1964, offers a framework for categorizing civilizations based on their energy consumption and technological advancements. The scale serves as a powerful tool for categorizing and contemplating our future trajectory as a species. The Kardashev scale is a four-tiered system that measures a civilization's ability to harness and utilize energy. The scale is based on the premise that a civilization's level of technological advancement is directly related to the amount of energy it can command. A Type 1 civilization, or a planetary civilization, has the ability to harness and use all the energy available on its home planet. This includes utilizing renewable energy sources, such as solar, wind, and geothermal power, to power their industries and meet their energy needs. They have achieved global unity and are capable of manipulating the resources of their entire planet. A Type 2 civilization or stellar civilization possesses the ability to harness the energy of their host star. They can construct massive structures like Dyson spheres or Dyson swarms to encase their star and capture its energy output. This civilization can tap into the vast resources of their solar system and utilize them to fuel their advanced technologies and interstellar exploration. A Type 3 civilization or a galactic civilization could utilize the energy resources of an entire galaxy, move planets, feed black holes with stars, and even manipulate the fabric of space-time. And a Type 4 civilization would be capable of creating a universe itself. According to this scale, we haven't yet reached Type 1 civilization status, but we're not a Type 0 civilization anymore. Human beings have a score of about 0.73 on the Kardashev scale. One famous theoretical physicist has estimated that if we increase energy consumption by 3% yearly, it would take 100 to 200 years to get us to Type 1 civilization. Once we achieve this status, we'll be able to utilize all the sunlight, wind, and tides available to us. Weather conditions would be controlled by our will, and we'd be able to alter the course of earthquakes and volcanoes and make floating cities. In a strikingly parallel manner, akin to the hierarchical classification of power utilization, different civilizations exhibit distinct methods of communication, which can make it difficult for them to understand each other. Type 1 civilizations, with their planetary scale energy utilization, are likely to rely on traditional communication methods such as radio waves, electromagnetic signals, and optical communication. However, as they ascend the scale, they may harness technologies that allow for more advanced and efficient means of communication. Type 2 civilizations, for instance, may employ advanced and sophisticated forms of long-distance communication, such as gravitational wave communication or quantum entanglement-based systems. Type 3 civilizations, capable of intergalactic travel, may utilize methods beyond our current comprehension, such as wormholes or subspace communication. Bridging these gaps is crucial for establishing meaningful and effective channels of understanding. In order for different civilizations to communicate successfully, they would need to use a common form of communication. In our early endeavors as a Type 0-1 civilization, we began by sending physical messages into outer space. These messages, encapsulated in various forms, served as a means to communicate our presence and curiosity to the vast unknown. As the first major initiatives to communicate with potential extraterrestrial beings, the Pioneer plaques and Voyager golden records were affixed to spacecraft sent beyond our solar system. The plaques, designed by astronomer Carl Sagan and his team, contained symbolic representations of humanity, including a map of our location in the galaxy and a silhouette of a human figure. Similarly, the Voyager golden record, curated by a committee led by Sagan, contained a collection of sounds, images, and music, showcasing the diversity of life and culture on Earth. The Voyager space probes are now 23 billion kilometers or 14 billion miles away from home, making them the farthest man-made object in existence. But while these messages symbolized our curiosity and desire for contact, they also present significant limitations in effectively establishing meaningful communication. The vastness of space poses a huge challenge when it comes to locating and encountering physical messages sent into the cosmos. Plaques and records launched into space are minuscule compared to the immense area they traverse. Space is vast and largely empty, making it highly unlikely for any extraterrestrial civilization to come across our plaques or records by chance. Additionally, physical messages such as the plaques and records are just a form of unidirectional communication. They serve as a representation of our existence and aspirations, but they lack the ability to receive or transmit responses from potential recipients. Even if an advanced civilization were to come across these messages, the absence of a means for them to respond directly hinders the establishment of a meaningful dialogue. The unidirectional nature of physical messages limits the potential for an interactive exchange of ideas, knowledge, and cultural understanding between civilizations. Lastly, the huge differences between celestial objects means that the journey of physical messages can span hundreds or even thousands of years. In the case of the Voyager golden records, for instance, it would take eons for any potential reply to reach us. The timescales involved in interstellar communication again make it impractical for immediate or real-time exchanges, impeding the possibilities of timely interaction and mutual learning. After 60 years of sending various signals and scanning the skies trying to detect artificial signals, we haven't been able to find anything. And we remain unheard. Nowadays, the main world institution devoted to the search for extraterrestrial intelligence is a project called SETI, an abbreviation for the Search for Extraterrestrial Intelligence. This project is based on the use of radio telescopes. Radio telescopes receive radio waves, as we can't go to space aboard spacecrafts. To find that intelligent life, what we look for are radio signals. Scientists use radio telescopes present around the globe to scan the skies for narrowband signals that conspicuously stand out against the backdrop of cosmic noise. It allows scientists to eavesdrop on the whispers of the universe. Just like tuning your FM radio to find the matching frequency of a radio station, scientists often search for signals in the water hole frequency range, which encompasses the hydrogen line and the hydroxyl line. The idea is that these frequencies are natural choices for communication. due to their proximity in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxyl, which are abundant in the universe. However, a big hurdle stands in our path. It's the language barrier. Language serves as the bedrock of human communication, allowing us to convey ideas, emotions, and knowledge. But when it comes to extraterrestrial beings, the very notion of language becomes difficult to understand. How do we decipher the codes of an alien civilization? What forms of communication would they employ? These questions lie at the heart of the language barrier of SETI, a challenge that their scientists and researchers grapple with every day. When attempting to decipher ancient languages, linguists heavily rely on contexts and comparisons to other languages to understand their meaning. However, when faced with the challenge of decoding an alien language transmission, these familiar tools are absent. No context is available, and there are no similar languages to draw comparisons from. And assuming aliens use a verbal language is a significant assumption, given that numerous animal species communicate without words. For instance, cuttlefish and chameleons communicate through body color languages, while ants and honeybees employ pheromones to communicate within their species. Even if we understood their language's letters and words, could we really understand what they're saying? Language for us is all based on cultures and requires a common frame of reference. If you were to say, "I'm going on a hike and capturing some stunning views with my drone to a squirrel in the park," it would have no way of comprehending your statement. You would need to explain what a hike is, what capturing means, what stunning views are, what a drone is, what technology is, what flying is, what cameras are, what video recording is, and even the concept of visual appreciation, all of which are intuitive to modern humans. If such a scenario were to occur, it's highly likely that the alien civilization is far more advanced than humans, having achieved interstellar travel and possibly even faster than light travel. Therefore, it becomes crucial for us to demonstrate that we possess at least a basic understanding of the universe in order to establish meaningful communication with them. Mathematics, as far as our knowledge extends, is a universal language, a language that transcends cultural and linguistic barriers. By harnessing the power of mathematical concepts, we may unlock a means of communication with alien civilizations. Foundational concepts such as addition, subtraction, multiplication, and division are universally applicable, serving as a framework for numerical communication. Regardless of location in the universe, the fundamental truth remains that 2 + 2 = 4, and the ratio of a circle's circumference to its diameter is approximately 3.141592, and so on. While the specific numerical labels may differ across civilizations, the underlying concepts remain unchanged. One approach to mathematical communication with aliens is through the use of bits. In digital communication, a bit is the smallest unit of information, represented by a binary value of 0 or 1. By using a series of bits, we can encode and transmit messages. For instance, we can allocate a unique series of bits to each letter of the alphabet, creating a binary code that represents written communication. Thus, we could introduce the concept that 1 bit signifies the letter A, 2 bits represent the letter B, and so forth. This binary code could serve as a foundation for communication, allowing us to transmit longer written messages that could be understood by an intelligent alien civilization. Therefore, we could show the aliens our understanding of math, though it would be a tremendous intellectual challenge humankind has ever faced. Composing a message that can be understood by aliens will be extremely difficult, and conversation may almost be impossible. Extraterrestrials could be millions of years more advanced than we are. These hypothetical life forms may have long abandoned their biological bodies to exist solely within a computerized body. In this scenario, they may have relinquished their individual consciousness to merge into a global digital network of minds, giving rise to a vast collective consciousness. Due to this huge intelligence gap and the absolute cluelessness about the possible aims of an extraterrestrial intelligence, is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials. However, even if there were potential risks involved, even if another civilization can come to Earth, it's already too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There's no added danger of transmitting signals through active SETI. Considering the information we now possess, it is plausible that a first contact could occur in the near future. It's also possible that some civilization has already listened to our messages, but haven't responded because they like it that way. All these processes talked about are known as active SETI or METI, Messaging Extraterrestrial Intelligence, which involves the intentional transmission of messages or signals from Earth into space. By taking a proactive role in initiating communication, scientists hope to attract the attention of intelligent beings that may be listening or capable of receiving the transmitted signals. This shift from passive observation to active engagement reflects a growing belief that humanity should actively participate in the quest to establish contact with other civilizations. Nevertheless, how is it possible that, given the huge possibility of other civilizations, we haven't yet received any evidence of their existence? The question of great silence was first raised by legendary physicist Enrico Fermi, and is famously known as the Fermi paradox. Speaking to his colleagues once during lunchtime, he raised a seemingly simple question. So, where is everybody? Why haven't we seen any proof of alien civilizations yet, given how likely it is that they exist? Perhaps, at the end of the day, maybe they simply don't bother to communicate with us. When you consider our civilization's level of development, the answer is pretty obvious. Why would they? The logistics required for interstellar travel are only available to civilizations that have reached Type 2 at the least. And in their eyes, we're not worth it. What person in their right mind would try to communicate with ants? How would an ant be able to recognize that someone's trying to communicate with it? After all, in terms of our development and technological advancement compared to them, we're akin to highly developed ants that have taken over an entire planet. This is called the zoo hypothesis. The extraterrestrials may have chosen not to initiate contact or reveal their presence for various reasons, such as respecting our development and not interfering with our evolution, avoiding potential conflicts or cultural clashes, or simply having no interest in communicating with less advanced civilizations. Another explanation for the Fermi paradox is that we may have already received those signals, but we haven't realized it. We haven't perceived the signals, or we haven't been able to understand or decode them. In this case, some strange signals from outer space have been received. Their origins are now being investigated, and they have posed serious questions for scientists. The most famous signal that has been detected came in 1977 at Ohio State University's Big Ear radio telescope. While listening for signals from another civilization, a strong message spread out over frequency was observed. It looked exactly like the kind of signal we would want to receive from extraterrestrial beings. During his work on the night shift on July 15, 1977, Jerry R. Amon, a professor at Ohio State University and a volunteer for the SETI project, observed the peculiar transcription of the radio signal made by a computer on a section of paper feed. Later, it was confirmed that this signal was the most intense anomalous signal detected up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals. It had come from the constellation of Sagittarius. The computer processed the received signals into a series of alphanumeric characters, producing the sequence 6EQUJ5. In fact, it was so astounding that when the technician looked at the printout the next morning, he wrote "Wow" in the margin. And that has become known as the WOW signal, which has kept the international scientific community on edge until today. Amon and his team conducted an exhaustive examination of the signal and eventually ruled out any interference coming from Earth. Over the following month, the operators of the radio telescope attempted to relocate the signal, but they were unsuccessful. Astronomers have looked at the same part of the sky many times since then, hoping to find the WOW signal again, but they have never been able to replicate it. The key to progress in SETI is to find a signal that is as remarkable as the WOW signal, but not just once. It needs to be found repeatedly. Today, the origin of that signal is still under investigation. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe. That's why human beings and their enthusiasm for knowledge and exploration have started the search for intelligent life with the hope of sooner or later finding it or being found by it. The first contact may not happen within our lifetimes, but whenever that occurs, it will be a turning point in the life of the human species. What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Will mankind be prepared? On November 13, 2004, scientists at NASA were using the Hubble Space Telescope to capture images of a previously unexplored and empty region of the sky. With low and minimal expectations, they did not expect a lot in return, just a dark and empty image, and the scientists could call it a day. The telescope would return, however, an image of a planet located just 25 light-years away from us, orbiting a star double the size of our Sun. This was the first time a planet was directly observed through a telescope. Against their expectations, the scientists could not wrap their heads around what had just transpired. Never before in history had a planet been found out on the basis of direct observation. In fact, the person who discovered it said he nearly had a heart attack. The image that was captured reveals a star at the center, now formerly known as Fomalhaut, which is surrounded by huge, swirling clouds of dust and debris. encircled by a continuous round asteroid belt. And among these millions of rocks dotting the image lies a planet surrounded by real mystery. Once named Dagon, this planet, clearly visible in the photo, never truly existed. What you're seeing right now is nothing but the phantom of a planet that never came into being. Astronomy has not yet encountered anything like this before. What could it be? A glitch in the matrix? Could someone else be involved? Where could a whole planet disappear to? In 2004, when NASA first discovered Dagon, something seemed off right from the start. It was behaving strangely, defying the odds. Because according to what we knew, planets like Dagon that are 2 to 3 times the size of Jupiter shouldn't have been able to form around such a young star like Fomalhaut, which is just 400 million years old. Our Sun, for comparison, is about 4.6 billion years old. Additionally, since its star is surrounded by a protoplanetary disk of gas, ice, and dust, the first planets to appear around it should be superheated and glow in the infrared, instead of this Dagon that emits ultraviolet light. Moreover, that planet was incredibly radiant, shining with an intensity rarely observed on exoplanets. Its remarkable brightness raised numerous questions among scientists, but for the most part, scientists just thought maybe it's the presence of an expansive ring system, akin to Saturn, which could enhance its reflective properties, thus intensifying its luminosity by capturing and redirecting more sunlight. And what's more, research showed that Dagon behaved in a very strange manner. Though it's unknown how much time it takes to make one trip around Fomalhaut, according to the estimates, the speed of the planet just kept on increasing while it cruised on its 1,700-year orbit around its star. During those early years, it seemed obvious that Dagon was acting in a way that a legitimate planet should not. Its unusual movements and unexplained appearance never stopped puzzling the research team. However, due to various constraints and shifting priorities in the scientific community, the resources were redirected to other projects, and the tracking of Dagon unfortunately came to a halt. Nevertheless, the Hubble telescope continued capturing its images over the years. This hiatus that lasted a decade came to a stop in 2020, when NASA made the decision to delve back into their archives, and what they found left them astonished. The planet had mysteriously vanished into thin air way back in 2014. Although in previous years the object was consistently registered by the Hubble Space Telescope, starting in 2006, the planet started increasing in size and becoming more dim until it decided to finish the scientists off and just disappear, as if it had never existed, leaving everyone perplexed and searching for answers. It looked like the planet didn't just vanish, but dissipated. Scientists had reached an impasse. All of these events went against everything the scientists knew about exoplanets until now. The researchers had to practically review the data again to come to a new radical conclusion that the planet Dagon never existed, and to substitute some other object in place of Dagon. One intriguing theory that emerged regarding the disappearance of planet Dagon was the notion that it was a rogue planet that was wandering through the cosmos rather than a permanent resident of its star system. This theory suggests that Dagon was not a permanent resident of its star system, but somehow got detached from its parent star, venturing into the Fomalhaut system, captivating astronomers who clicked its presence in the nick of time and eventually departed the Fomalhaut system. The idea of a planet on the move, untethered from a star's gravitational pull, added a layer of intrigue to the mystery. What cosmic forces guided Dagon on its trajectory? Did it also encounter other star systems along its path, engaging in gravitational dances that reshaped its course? As scientists delve deeper into the intricate dynamics of the Fomalhaut star system, a more plausible explanation emerged. Extensive analysis of the system's gravitational interactions and the presence of a massive debris disk revealed that the likelihood of Dagon being an elusive wanderer was slim. The complex gravitational forces exerted by the stars and the constraints imposed by the surrounding debris disk would have significantly hindered the planet's ability to roam freely without being influenced or detected. And if planet Dagon had indeed been a rogue planet traversing the system, it would have left discernible traces of its passage in the surrounding debris disk. Much like the trails formed by the wings of an airplane on clouds. Just as these trails offer evidence of the airplane's presence and movement, astronomers expected to observe distinctive disturbances or patterns within the debris disk caused by the interaction with Dagon. Yet, despite meticulous examinations, no significant indications of such disturbances have been found. The absence of discernible breadcrumbs, akin to the trails formed by airplane wings in clouds, raises doubts about the hypothesis of Dagon as a wandering planet. Scientific scrutiny, guided by evidence-based reasoning, compelled scientists to explore alternative explanations for the vanishing of planet Dagon. A new and the most possible theory proposed by the scientists suggests that the object originally interpreted as an exoplanet was a slowly dissipating dust cloud that formed as a result of a massive collision between two asteroids or planet fetuses, each about 200 kilometers or 125 miles in size. This discovery is even more amazing because a collision between two small celestial bodies is incredibly rare. The ability of scientists to capture the image of the collision was an incredible stroke of luck. In the vastness of space, where distances are unimaginably immense, such collisions between celestial objects are estimated to occur once every 200,000 years or so. The collision must have happened back in 2004, when the Hubble telescope was surveying the area around Fomalhaut. Coincidence number one. As time went by, the dust began to spread, which explains the increase of the object's size and the lowering brightness. Coincidence number two. And the dust cloud that formed in the collision explained the eccentric orbit. Coincidence number three. And so a string of incredible coincidences confused the astronomers and created a beautiful legend about a strange and unpredictable planet Dagon that does not look like a planet or move like a planet, does not revolve around a host star or an elliptical orbit like a planet, and instead moves along a runaway trajectory that eventually takes it far away from the star. It was an extraordinary occurrence that they were able to witness and document this event, defying astronomical odds. After connecting all the dots and examining the accumulated evidence, scientists ultimately concluded that Dagon, once considered an exoplanet, should no longer hold that status. Currently, it's believed that planet Dagon's dust cloud, resulting from a colossal collision, must span an impressive expanse of 300 million kilometers. It must be composed of tiny dust particles measuring just 1 micrometer in size, surpassing the scale of any known planet. This massive yet tiny dust particle cloud has rendered Dagon invisible to the Hubble telescope. The disappearance of planet Dagon provides a rare opportunity to study planetary collisions, unraveling their dynamics and aftermath. Computer simulations and observations have revealed that powerful space collisions can even transform celestial objects into expansive clouds of fine particles. The similarities between the Dagon collision and our solar system's early stages are also significant. By analyzing the debris and its composition, scientists gain insights into the processes that shaped our cosmic neighborhood billions of years ago. The scattered particles in the Fomalhaut star system offer valuable information about the building blocks of planets and the conditions that facilitated their formation. This knowledge enhances our understanding of planetary systems and fuels our exploration for extraterrestrial worlds. But this ain't the first time an object in space vanished before scientists' eyes. A similar tale occurred with exoplanet Alpha Centauri b. In 2012, astronomers at the European Southern Observatory detected fluctuations in the radial velocity of a star using the precise HARPS spectrograph. These fluctuations could only be caused by a planet's gravitational pull. This breakthrough method, known as Doppler spectroscopy, is highly reliable, with only a 0.1 margin of error. With just one miss among 1,000 hits, it ignited a profound sensation within the scientific community. This fervor was further heightened by the fact that Alpha Centauri b, situated a mere 4.5 light-years away from our solar system, stood as the closest exoplanet in proximity. Astronomers revealed that this planet orbited its star too closely, outside the habitable zone, with surface temperatures reaching around 1,200 degrees Celsius, nearly 3 times hotter than Venus. Scholars eagerly sought to calculate its orbit parameters, but before they could do so, Alpha Centauri b vanished into thin air, 3 years after its 2015 discovery. Reanalyzing the data, experts at the University of Oxford discovered that the velocity fluctuations initially seen as proof of the exoplanet's existence were, in fact, just calculation errors. However, it's downright bizarre when, instead of a planet, a star mysteriously vanishes, after being diligently studied for a solid 10 years. From 2001 to 2011, numerous astronomical teams locked their gaze on a luminous blue variable star nestled within a dwarf galaxy called PHL 293b, situated 75 million light-years away. Their aim? To learn more about how these types of stars end their lives. These luminous blue variables have a distinct and unmistakable light signature. They're colossal, supergiant, or hypergiant stars, teetering on the precipice of their life cycles. Bursting with brightness and plagued by instability, they undergo violent outbursts and eruptions that cause drastic fluctuations in both their radiance and spectral characteristics. During these dramatic episodes, their luminosity can even double in intensity. Staying true to the nature of these luminous blue variables, our mystery star under scrutiny in its advanced life stages shone brightly with its radiant luminosity. However, when scientists directed the powerful, very large telescope of the European Southern Observatory toward the PHL 293b galaxy in 2019, the star had mysteriously vanished. A meticulous analysis of data collected between 2011 and 2016 revealed an unsettling truth. it had ceased to be visible after 2011. According to astronomers, only two primary possibilities could emerge from this point. Firstly, it's plausible that the star dimmed and became veiled within a shroud of ejected material, resembling the ambiguous dust cloud that may have concealed our very own Milky Way's red giant star, Betelgeuse, a couple of years ago. Under this scenario, the star might have continued its eruptions concealed behind this thick fog of gas and dust, rendering it invisible to our eyes. Infrared observations conducted in 2009 hinted that this obscuring cloud would need to be chillingly cold to remain undetected and enshroud the star effectively. Alternatively, based on certain models, it is proposed that the luminous blue variable star, rather than undergoing the anticipated supernova phase, skipped this explosive spectacle altogether and transitioned into a slow-spinning black hole. This notion gained support from recent research on a colossal red star that rapidly brightened before abruptly vanishing in a galaxy located 22 million light-years away, published back in 2017. The researchers hypothesized that this star had experienced a failed supernova before its ultimate collapse. Building on these findings, the team postulates that the luminous blue variable star in PHL 293b was also in an eruptive state between 2001 and 2011, after which it vanished either by bypassing the supernova stage entirely or faltering in its attempt to initiate one. In most cases, stars nearing their end typically culminate in a spectacular supernova before transforming into either a black hole or a neutron star. This explosive phase is hard to miss, often persisting for several years. Astronomers would have undoubtedly caught a glimpse of such an explosion if it had occurred. This puzzling situation challenges our understanding of stellar life and death, forcing us to reconsider our existing models. With the currently available information, the enigma of the missing star presently remains unsolved, leaving astronomers eager for future measurements across various wavelengths to unlock the secrets shrouded within this cosmic riddle. In 1972, an extraordinary spacecraft named Pioneer 10 embarked on a thrilling mission to explore the vastness of the asteroid belt and the colossal gas giants that dominate our solar system in the outer reaches. Traveling at a speed of 32,000 miles per hour, or 51,500 kilometers per hour, Pioneer 10 soared away from Earth on a transformative journey that would eventually pave the way for future endeavors, such as the Voyager probes. While the Pioneer mission ultimately achieved remarkable success, it was not without its fair share of challenges and obstacles. Little did the world know the probe had carried with it a hidden problem, a riddle that would puzzle even the brightest minds and astrophysicists for decades. Plagued with a number of malfunctions, Pioneer 10 has sometimes been referred to as the luckiest spacecraft ever launched. Sometimes a few instances in our lives dare to challenge our basic and fundamental theories. In the early 1980s, while the probe was still in contact, scientists had noticed something quite intriguing. The probe was both slowing down and veering off course, as if an unknown force in space was putting the brakes on and tugging it back toward the sun. Despite conducting extensive research and tirelessly analyzing data for about 15 years, the solution to this puzzle remained elusive. Instead, the slowdown came to an abrupt end, leaving behind one of the greatest mysteries in the history of spaceflight. Even today, the flyby anomaly continues to confound our understanding of spaceflight, causing some spacecraft to deviate ever so slightly from their intended trajectories. It remains a glitch that tests our knowledge and leaves us searching for answers. Launched back in 1972, Pioneer 10 became NASA's pioneering mission to the outer planets. The probe earned its moniker from the valiant pioneers who settled the western United States, because, just like those explorers of old, Pioneer 10 aimed to boldly go where no spacecraft had gone before. Pioneer 10 spacecraft achieved remarkable triumphs, marking several firsts in our space exploration. It was the first to venture beyond Mars, traverse the asteroid belt, and reach the mighty gas giant Jupiter. Pioneer 10 also made history as the first spacecraft to utilize an all-nuclear power supply and follow a trajectory that would lead it beyond the boundaries of our solar system. Originally intended for a modest 21-month mission, Pioneer 10 far exceeded expectations, defying the odds and persevering for over 30 years. However, in January 2003, after its long and distant journey, the venerable probe bid its final farewell, transmitting its last signal back to Earth. Today, Pioneer 10 continues its cosmic voyage, a solitary vessel drifting like a ghost ship through the frigid expanse of space, over 11 billion miles away in the opposite direction of the Sun's motion through the galaxy. Just like its twin, Pioneer 11 took off into the great unknown a year later in 1973. Following in the footsteps of its predecessor, it became the second probe to successfully pass Mars, navigate the main asteroid belt, and reach the majestic planet Jupiter. Finally, Pioneer 11 etched its name in history by becoming the first spacecraft to fly by Saturn. Unlike its twin, however, after leaving Saturn, Pioneer 11 headed out of the solar system in the opposite direction at an angle of 90 degrees to Pioneer 10. Its destination? The center of the galaxy, present within the constellation of Sagittarius. In 1995, NASA received the last signal from Pioneer 11, marking the end of its communication. It silently vanished into the depths of space, leaving behind a legacy of exploration. But unknown to many, both of them had left behind a puzzle that would baffle even the most seasoned physicists for decades. Just like many confusing puzzles, this one began with a subtle hint of inconsistency. Shortly after Pioneer 10 and 11 ventured beyond the orbits of Jupiter and Saturn, their navigators made a surprising discovery. Both spacecraft appeared to be experiencing a greater slowdown than what the navigators had initially anticipated. It was as if an unknown force was gently tugging them backward, closer to the Sun. While the scientists were aware that the probes would naturally decelerate to some extent due to the Sun's gravitational pull, the data revealed an excessive slowdown that defied explanation. The deceleration experienced by the spacecraft was incredibly small, just merely 1/10,000,000th of Earth's gravitational acceleration. In 1998, John Anderson of JPL and his colleagues calculated that the spacecraft had a deceleration rate of about 300 inches per day. While this may seem like a very small difference in measured acceleration compared to the predicted values, it had significant implications. The pioneers ended up staying thousands of kilometers closer to Earth each year than originally intended. They fell short of their expected location by a distance roughly equivalent to the distance between the Earth and the Moon. Year after year, the spacecraft found themselves deviating by a few thousand kilometers from their expected positions. Initially, it hadn't raised many concerns, but now it was a different story altogether. And the puzzling part was that this tiny deceleration persisted as the spacecraft traveled deeper into space. There were also two other spacecraft that encountered trajectory issues. One was Galileo, launched in 1989 to study Jupiter and its moons. The other was the Ulysses spacecraft, launched in 1990 to explore the Sun. Both of these missions faced trajectory anomalies that left scientists scratching their heads. Scientists exhaustively explored various possibilities to explain these decelerations. They considered everything from gas leaks to the expansion of the universe. However, despite their efforts, no conclusive answer was found. Due to the lack of explanation for the slowdowns, the team hypothesized that it could be attributed to some new physics that contradicted Einstein's general theory of relativity. This even raised the tantalizing possibility of undiscovered phenomena that could reshape our understanding of the universe. In 2004, Slava Turishev, a physicist at NASA Jet Propulsion Laboratory, had a thought brewing in his mind. He contemplated building a brand new probe to investigate the Pioneer anomaly to get to the bottom of it. This new probe, however, unfortunately never took flight beyond the confines of the drawing board. Slava had to work with the data that was available, and he didn't have any fresh data to work with, since the two spacecraft had stopped communicating with Earth. But that didn't deter Slava, though he faced a couple of more challenges along the way. Firstly, those Pioneer spacecraft were designed back in the day when computer-aided design wasn't in the picture. It was all good old-fashioned paper and pencil. So he had to start from scratch and create 3D models himself. Secondly, NASA didn't require achieving mission records, making it quite a task to locate the data. Despite these setbacks, Slava and his team searched through old Pioneer communications and data, unearthing digitized files from JPL navigators and seeking additional information from various NASA centers. They discovered boxes of magnetic tapes at NASA's Jet Propulsion Laboratory and magnetic optical tapes at NASA's Ames Research Center. A programmer named Victor Toth from Canada joined forces with Slava and helped create a program to read and structure the data. In the end, Slava and his team collected over 43 gigabytes of information. That doesn't sound like much by today's standards, but back in the 1970s, it was an incredible trove of data. So what did he find? The answer to the anomaly resided in the structure of the probe itself. You see, NASA engineers had to spin the Pioneer probes to maintain stability and ensure they remained pointed towards Earth. This was necessary because the antenna needed to be directed towards Earth to exchange data. On the other hand, the Voyager missions had a more advanced technology that used thrusters to maintain spacecraft stability. However, what was causing the deceleration? It was discovered that the deceleration was due to thermal radiation emitted by the spacecraft. There were two sources of thermal radiation positioned on the leading side of the spacecraft. The first source was the electric box. and the second was the radioactive material responsible for power generation. Both of these sources emitted heat in the direction of the spacecraft's motion through space. This emission of heat created a small photon pressure in the opposite direction of the spacecraft's motion, resulting in the observed deceleration. It's the same principle that operates in a solar sail, where the spacecraft is propelled forward as photons from the sun collide with it. Now, here's the interesting part. The slowdown of the Pioneer's probes came to a sudden halt when the radioactive material was completely used up. With the wealth of new data at their disposal, Slava and his colleagues were able to calculate the amount of heat generated by the electrical subsystems and the decay of plutonium in the Pioneer power sources. These calculations perfectly match the anomalous acceleration observed on both Pioneers. But other spacecraft like Galileo and Rosetta took into account the thermal recoil, yet they still encountered deviations in their paths. When the Galileo spacecraft was on its way to Jupiter, something peculiar happened during a gravity assist maneuver where it flew past Earth. Scientists noticed an unexpected increase in the spacecraft's speed. There was a discrepancy, a difference in speed relative to Earth, with an unanticipated boost of about 4 millimeters per second. This effect, known as the flyby anomaly, has affected almost every spacecraft out there. The flyby anomaly reveals something quite intriguing. Some spacecraft actually gain more speed when traveling to or away from Earth than what scientists initially predicted, and so far no convincing explanation has been found. The flyby anomaly made another appearance during the Near-Shoemaker incident in 1998. This mission had its sights set on studying the asteroid 433 Eros. To reach its target, the Near-Shoemaker spacecraft performed a flyby of Earth. And guess what? Scientists observed an even larger deviation in the spacecraft's velocity compared to the Galileo flyby. This time, the speed unexpectedly increased by around 13 millimeters per second. The recurring nature of this phenomenon in these two cases piqued the interest of the scientific community. They started delving deeper, reviewing data from other flybys. As they dug into the records, more cases emerged. The Messenger spacecraft's flyby of Earth in 2005 and the Rosetta spacecraft's flybys in 2005 and 2007 all revealed similar anomalies in their velocities. This was no longer just an isolated incident or a measurement error. The flyby anomaly had accumulated enough evidence to demand serious attention. Numerous theories have been put forward to explain the flyby anomaly, ranging from the mundane to the extraordinary. One hypothesis focuses on the shape and composition of our planet. You see, the Earth isn't a perfect sphere. It's more like a spheroid due to its rapid rotation. It has varying densities and features like mountains, oceans, and ice caps. As spacecraft fly past Earth, they might expect different gravitational forces depending on the specific features they encounter. The challenge with this theory is that there are countless spacecraft orbiting Earth all the time, and if this explanation were correct, we would expect them all to experience the flyby anomaly. So there must be more to the puzzle. Another proposal suggests that the configuration of the Moon or other planets in the solar system during a flyby, along with the positions of the ocean and tidal conditions, could be contributing factors. Even though the Earth's atmosphere is thin at the altitude of flybys, it's possible that even the minuscule number of atmospheric particles encountered could affect the spacecraft's trajectory. Some researchers believe that the Sun might play a role in the anomaly. It's possible that the spacecraft experiences varying levels of solar winds during each flyby. Some scientists propose that relativistic effects could be at play. The rotation of the Earth, for instance, might create distortions in the surrounding space-time, ultimately altering the spacecraft's trajectory. As you can see, the flyby anomaly is a complex puzzle, and the search for an explanation continues. Scientists are diligently exploring these various theories, conducting experiments, and analyzing data to unlock the secrets behind this intriguing phenomenon. To delve into the predictions of Einstein's theory of relativity, scientists are proposing the launch of an existing new spacecraft named STEP, which stands for Satellite Test of the Equivalence Principle. This mission was selected by the European Space Agency back in 2012, and if it gets the final green light, it will be sent into space by 2024. STEP's sole purpose would be to study gravity, aiming to achieve the most sensitive measurements of gravity ever made. This remarkable spacecraft would orbit the Earth, equipped with an incredibly precise clock on board. Shielded from radiation in the vast expanse of the universe, it would have the freedom to observe and analyze gravity. With its exceptional sensitivity, it could detect both the gravitational forces exerted by the Earth and the Sun to an astonishing accuracy of 10 to the negative 7th power. The spacecraft would follow an orbit that takes it through the various distances at which anomalies were observed during flybys. If gravity is indeed the cause of these anomalies, STEP should be able to precisely demonstrate how the magnitude of the effect changes with distance from Earth. Thus, while STEP's primary focus is on advancing our understanding of gravity, it also holds the potential to finally unlock the secrets of the flyby anomaly. Throughout human history, we've built an incredible body of knowledge about the universe around us. However, we're only at the beginning of this journey. The universe, a twilight realm of enigmatic secrets, remains replete with unexplained mysteries and paradoxes, shaped by unseen forces. It's like a giant jigsaw puzzle made up of an infinite number of pieces, but we can only see a small part of it and can only guess the rest. In the vastness of the cosmos, many more countless mysteries await our curious minds. There are still many secrets yet to be discovered, enticing us to unravel the mysteries of the universe.